My name's Ali, co-founder and CEO of Cosine. We're working on building a fully autonomous software engineering colleague. And to do so, we've taken an interesting approach. We've decided to go down a fine-tuning route, like a data-first route. And the presentation I'm about to show you, and the demo I'm about to show you, is what we showed to OpenAI's fine-tuning team when we had finally got all the results and everything together from what we've been working on for the past 9 or so months. Truthfully, the reason for that is because I didn't prepare early enough for this, so I had to have some sort of presentation to give. So this is a heavily modified version of that. So to kick off, Genie is a fully autonomous developer agent. So we're not here to build a co-pilot. We're not here to work in your IDE. We're not here to try to make you faster. We're here to try to have a pass at a task before it even reaches you. As a developer myself, I can say that a huge amount of my time is spent doing things I don't want to do, and I'd quite like to free up a lot of that time to do things I do want to do. So we really want Genie to be taking the first stab at 70–80% of tasks that you should be assigned, and hopefully to be able to get those off your plate, and so you can really focus on what you want to do. To do this, we had to develop a data pipeline to accurately derive human reasoning and other things from real software engineering examples. As I said, this is a fine-tuned model. This is not a prompted model. So the thesis was really to show a model how to do software engineering like you or I do it. The way we did this is we ended up fine-tuning a very long context, well, not very long context, GPT model on this data set. We were able to get access to train GPT-4 Turbo back at the back end of last year, and continuing to work with OpenAI, we got access to train GPT-4o later on, and all of the work that I'm going to show you was done with that. Genie can be run headlessly or through Cosine's platform. I'll be showing it to you on Cosine's platform this evening, but the idea is also like you can assign Genie a ticket on Jira or Linear or whatever it is, and it should be able to have a go, and then you can go and find it where you work in GitHub as well to go review that PR as if you or one of your colleagues did it. So a bit more on our approach. As I say, we started with real examples of software engineering. What are those? Well, they're obviously like commits, PRs, issues. And then we had to take those what are essentially finished artifacts, what is a collection of diffs, and figure out why they came into being. Oftentimes on PRs, that information doesn't exist, so we had to go ahead and figure it out. This was basically the bulk of all the work we did over the last 9 months. So figuring out, given the answer, how did we get there? The things you need to find in order to make this work well are you need to be able to find things like unedited files, you need to use both static and LLM-powered methods, and often fine-tune models in order to derive the data for your fine-tuned model. And then some places the data just doesn't exist, so you have to use things like self-play and self-improvement to be able to synthetically generate that data effectively and make sure that data is clean enough to then train a subsequent model to be able to do those things. So the fine-tuning, as I said, we predominantly fine-tuned GPT-4o. This snapshot as our base model. We started off way back using GPT 3.5 16K, and that's what we took to OpenAI in order to sort of prove the concept of them. So because we knew we needed a long context model. Each training run was in the region of 100 million tokens. This is a bit out of date now, and we're now at about 250 million tokens. And some runs were additive, so we did train a model and then train on top of that model later on. We, interestingly, mainly used automatic hyperparameters. OpenAI's API is pretty good at this, and we didn't feel the need, given the dataset size, to really tweak that much. And now I'm going to give you a quick run through of how Genie fits into our platform, should the internet work. So Genie lives in Cosine's web platform. Very easy to set up. Essentially, you sign up and you hook into your own GitHub, and then all your projects show up. You can import new projects very easily, so you can just go in here, select a repo that you have, and then you can hit import. And what happens then is a huge amount of stuff gets kicked on AWS. Yeah, lib Volkswagen is for making your failing unit test look like they're passing, by the way. The idea is that when you kick off one of these jobs, a huge amount of stuff happens on AWS, and we index your entire code base in a number of ways. We create a keyword index, full semantic index, LSPs get run, all that stuff. So all the RAG that Genie then needs to do is available to it. And then once you've done that, you can then click on any of these. So for example, this one, and then this is where, if you want to, you can start creating tasks for Genie in the platform. So I can go in here and I can hit create. I can either start from a natural language prompt, or I can go ahead and start from like an issue or a linear issue or something like that. So Genie itself, I will actually move that later on. So what does Genie take in? Genie takes in anything really, a natural language prompt, a ticket from any of these people, and GitHub issues. It can also take in, once you've done that, issue and review comments, just like on GitHub, and it also listens for your CI runs, so it can see how the code it wrote did. Then it can also receive as input like files, docs, URLs, and it can go ahead and reach out to those whilst you're telling it what to do, so it can inform itself with whatever documentation you want to read. The way the loop works with Genie is it's an interesting one. Genie is actually made up of two models. It's made up of a problem reproduction model and a problem solving model. The problem reproduction model is only really needed when you're doing things like bug fixes or swe-bench or things like that, when you're solving issues where you have a problem and you need to be able to measure whether you fixed it or not. If you're doing feature development or any front-end work or something like that, we don't use that model because you obviously don't need it. Within each one, there is a loop of retrieval, execution, and then code writing. And within each of those, the retrieval step was trained through self-play, as I mentioned earlier. Execution, we can use the CI for, and code writing, Genie is trained to write a sort of customized version of Git diffs. For any of you who've ever tried to make LLMs write diffs, they're not very good at it. So we had to modify the way that the diff format worked to make sure that they applied effectively. So what does Genie output you? Genie can output retrieval requests that then are the index that we just mentioned can deal with. As I said, it uses a custom diff format. LLMs are poor at Git diffs mainly because an autoregressive model having to output a context line for a hunk before it's actually written the hunk is very hard, so they don't work very well at that. And then they can also output comment responses. So if you left a comment on a GitHub PR, for example, it can respond to you. We really had to clean these because it turns out that a lot of open source comments are really snarky. A lot of emojis, and sometimes it would just say LGTM to like everything, and that's really unhelpful. So we had to really clean those. And in terms of what's coming soon, we're going to have things like task clarification, feasibility estimation. This is really important because, interesting from like a UX point of view, I think a lot of people would rather a product tell you up front whether it's going to be able to do the task or not, as opposed to taking a really bad stab at it. So this is an interesting one as well because I don't know if anyone has kept up with swe-bench or anything like that, but recently swe-bench verified came out, and that was by OpenAI, and they annotated all of swe-bench, and it's an amazing data set because essentially all of the swe-bench tasks were categorized in terms of difficulty and feasibility. And you can then use that annotation from OpenAI that they open source to then train models to be able to look at problems and tell you whether they're going to be feasible or not given the problem. So that's going to be coming into Genie as well. So before I get on to the demo, some really interesting things we saw with the model. This was the most interesting bit to OpenAI. The performance of GPT-4o degrades fairly linearly over the context window. I didn't expect this at all, but what it means is it's really interesting for people working on this problem because fundamentally, if your task is long enough, you're just up against it with a model. Like if you're over 60,000 tokens, you're more likely to fail than you are to pass just by the amount of stuff in the context window. This poses an interesting problem from us because if we want to make Genie better, well, where do we focus our efforts? Fundamentally, I could put loads of time in trying to make it better down here, but if the foundational model itself is, lacking there, it might be a waste of my resource. So this is an interesting one. I'm sure some of you will have realized this as well. Like the more messages you have in an LLM context window, the more we see repetition. And I also managed to get the average log prob for all of our swe-bench run, so you can see where in the context window the LLM was uncertain. So up front is where all the RAG happens. In the middle here is where we do like coding, so the model is much happier with coding than it is for retrieval. And at the end here, we actually don't know why it tails off at all. This is the same question for, as you can see, we split the RAG and the coding separately there. So if you, again, like beyond that 60,000 tokens mark, and you guys might have seen this using these models, your accuracy starts going way down and you start having far more like chance of hallucination. So now I only have 2 minutes left, so I will do my best to get a demo in. As I said earlier, Genie, you can start a task like this. So I know that there is a currently open issue on this repo that's to do with a crash. I'm just going to search for a crash. And yes, we're going to crash if there aren't any certificates. So this is the issue. It's pulled in from GitHub. And I'm going to kick start. And in the interest of time, because I have 2 minutes left, I'm actually going to one I made earlier because okay, that's done that. Let's reload that. Yes, phew. So this is one I did earlier, and essentially the way it works is, you can see the input here, and we have this sort of like tree-like graph thing. So if I click on this execution, you can actually see the change it made, and these will become editable very shortly because we want everything to be editable in this UI. And you can also do a follow-up prompt to Genie. If you didn't like what it did, as you'd expect, you can give it a follow-up prompt and it will continue working. As you can see here, it did what I wanted it to do. So here the tests actually passed. So it made a change. This was its chain of thought whilst it was coding, and then it ran some tests down here, and those tests passed. And I wanted to add a new unit test for the problem that we found in the issue, which is a fairly common thing to do. So I just said, great, can you please write a test for this now? And following on from that, it went ahead and it wrote a unit test for that, importing all the correct things. And then it ran those, and once again, the test passed. So that is a very brief overview of how Genie works and how you can use it. Again, you can do this fully headlessly through your issue tracker of choice. But yes, this is how we got to state-of-the-art score on swe-bench, and this is how we intend to allow people to use it and how we believe software engineering will happen in the future. So happy to answer any questions in the remaining 50 seconds I have.